Hello, I'm Mr. Miller. You're a bright young math student, and this is video 5B. Okay, everyone's been introduced. This video is about stretches, reflections, and shifts of parabolas. Okay, so let's get started with some examples here. So we want to consider the difference between y equals x squared, that's the most basic parabola called the parent function, and y equals ax squared. What happens when we multiply the original function by a number? Well, it depends on what a is. But when we're multiplying by a function by a number, we know it's going to be a vertical stretch, a shrink, or reflection, or a combination of those. All right, so here we have y equals 3x squared. We're multiplying the original function. Remember, the original function was y equals x squared. We're multiplying it by 3. We know that's going to be a vertical stretch by a factor of 3. Okay, let's go down and do this one. We're multiplying by a third. That's something less than 1. When we multiply by a number less than 1, it makes something smaller. So this is going to be a vertical shrink by a third. Okay, let's do the negatives. Well, multiplying by 3 was a vertical stretch. Multiplying by negative 3 is going to be a vertical stretch also, but it includes a reflection. So this one is going to be a vertical stretch and a reflection. All right, this one, kind of like this was a vertical shrink. This is going to be a vertical shrink also, but because it has a negative, it's going to be a vertical shrink and a reflection. Okay, well, let's illustrate this a little bit with Desmos. So I went to Desmos.com and I graphed, the first thing I graphed was the parent function, y equals x squared. And I'm going to turn that back off for a minute. And then I had Desmos graph y equals ax squared. When a is 1, it's really the same thing. If a is 1, we have y equals 1x squared, which is just x squared. But Desmos allows me to put in a slider, and we can change the value of a and see what happens to the graph. So when we multiply by a number greater than 1, we see that the graph is getting skinnier. What it's doing is it's stretching up. It's also kind of shrinking in, but we want to focus on what's happening vertically. So it's stretching up and getting skinnier. So if I put the original back here, for instance, this point maybe right here has stretched all the way up to that point. This point right here has stretched all the way up to this point on the purple graph. So we can see how points on the green graph like this have moved upwards. And so the graph has kind of gotten taller and skinnier in a sense. All right, so that's what happens if a is greater than 1. If we slide a down so that it's a fraction between 0 and 1, we see that the purple graph is getting wider. All right, that's a vertical shrink. The points on the green graph are moving down. All right, and so the parabola gets wider, and then as we go to negative values of a, we see that in this case, since we have point 2, is wider and reflected down. And then as we make a get more and more negative, it gets skinnier, right? It gets kind of vertically stretched. All right, so let me turn the green graph off and let's go through this really quickly again. There's the original, And as I increase A, it gets stretched and skinnier. As I decrease A, it gets wider. So that's a vertical shrink. And when I get negative, it flips over. And as it keeps getting more and more negative, all right, we see that the graph gets skinnier and upside down. So that's the effect of A, right? So it's either a vertical stretch or vertical shrink or reflection. So now we want to talk about shifts. Our original function was y equals x squared. And what we've done is we replaced x with x minus 5. So anytime we do that in a function, you replace x with x minus a number, it shifts it to the right by 5. So this would be a horizontal shift to the right by 5. Same thing here. If we start with a function and we replace x with x plus 9, we're doing something to the input, the argument of the function. That's going to shift it to the left by 9. Okay, here's a combination of two things. We replace x with x minus 4 on the inside, so that's a shift to the right by 4. But on the outside of the square, we have plus 2. That's a vertical shift up by 2. We did this earlier. It looked kind of different, but we started with a function f of x, and we learned that if we replace x with x minus 4, whatever the function is, that's a shift to the right by 4. And if we take that and we add 2 on the outside, we learn that that's a shift up by 2. This is really talking about the same thing, but we have a specific function we're talking about, the square function or the quadratic function. All right, this one, we've replaced x with x plus 1, so that's a shift to the left by 1. And this minus 8 on the outside, that would be a shift down by 8. Right here, I want to take a look at decimals again. And I have this typed in, x minus h parentheses squared plus k. So when h and k are 0, I really just have the basic graph, y equals x squared. So I want to see what happens when we change h. Now, h is being subtracted. We know it's a shift. It's on the inside of the square. We know it's horizontal. So when I change the value of h, we should see it move left and right, and we do. By making h bigger, it shifts it to the right more, and by making h smaller and going negative, it shifts it to the left, okay? So h controls how much it's been shifted. That's related to the horizontal shift. All right, so I'm going to put that back at 0 for now. When I change k, that's on the outside of the function. That controls how much it's shifted up or down. So when I move that, it moves it up. If I go the other way, it moves it down. So when we kind of combine these, we get a shift to the left or right and a shift up or down. We can kind of move our parabola anywhere we want. Now for this example, we want to complete the table below. So we want to identify what kind of shift these were. These are all shifts. There's no stretches or shrinks in these. So, all right, and then we want to identify where the vertex of the parabola is. The vertex is the turning point. It's originally at 0, 0, and we want to see where it's been shifted to. Okay, well, this first one is y equals x squared plus 2. The 2 is on the outside, so I know that's a vertical shift. So that's a shift up by 2. I'm going to kind of minimize my writing. Well, the original vertex of the parabola, like I mentioned, is at 0, 0, the origin. So if we shift the parabola up 2, the coordinates of the vertex would be 0, 2. It moved up 2. So x didn't change. Y went up by 2. All right. This one, this minus 7 is on the outside. So that's a vertical shift down. And if we move this parabola down, the x-coordinate of the vertex would still be 0. The y-coordinate would be at -7. All right, this is not something that happened on the inside of the square. We changed the argument. We did something with x. We replaced x with x minus 3. This is a shift to the right by 3. If we move the parabola to the right 3, the x-coordinate of the vertex would be 3 and the y-coordinate would be 0. This is a shift to the left 6. So if we move it to the left, the vertex would now go to -6 on the x-axis. This is a combination. We have x minus 5 on the inside. That's to the right 5. And we have a -9 on the outside. That's down 9. So if we move our parabola right 5 and down 9, that vertex would move to 5, -9. All right, last one. This is x plus 1 means we move to the left 1. The plus 5 on the outside means we moved up 5. So if we move left 1, x would be -1. And up 5, y would be 5. That would be the new vertex. Okay, all right. So we're ready for the journal assignment. Your goal is to identify what kind of transformation this was. So some of these are stretches, some of these are shifts, and some might be reflections. All right, give it your best.